Welcome, everybody. I'm very happy to be here and to be able to speak about R2DBC, which stands for Reactive Relational Database Connectivity. So what is R2DBC all about? This is something that we will learn in this session, but let me introduce myself first. My name is Mark Paluch. I'm project lead of Spring Data. In Spring Data, if you don't know that, it is an umbrella project for various store modules, which ranges from JPA over MongoDB to Redis, basically a collection of Spring Data modules for relational databases, for non-relational databases, basically all kinds of data stores out there. I'm also spec lead of R2DBC. That's probably the reason I'm here today. I'm maintaining as well the Redis driver Lattice, and in my free time, I'm producing electronic music. If you want to connect with me, then go to my Twitter profile. You will find me there, also links to my music. And if you want to connect with me on the code base level, then go to my GitHub page and you will find all my repositories there, as well as a bit of example code for R2DBC. That being said, let's get started with the talk itself. Now, what is R2DBC? R2DBC is a community-driven specification that brings reactive programming and SQL databases together on the JVM. It is up to now the de facto standard if you want to program reactively on the JVM with things like Java or Kotlin using coroutines, and if you want to integrate with SQL databases. Before that, there was no real standard, and folks had to really use vendor-specific technologies to connect the application to the database. R2DBC is based on Java 8 and reactive streams to really lower the barrier to entry. You know, there are lots of active Java versions ranging from 9 to 17, and you have a lot of choice there, but not every application is ready to adopt a newer Java version. So we decided to use an as low foundation as possible. And with Java 8, we have all the benefits of a functional programming approach with a pretty modern standard still. The current released version is R2DBC 0.8. 0.9 is a development version, which is still under development, and it's going to be released soon. When we started evolving around R2DBC, we set ourselves a few design goals and design principles. We want to embrace reactive types and reactive patterns everywhere to create a specification that feels and works natural to reactive programming. We want to be non-blocking right from the beginning of your application down to the database itself. So you will have an end-to-end reactive experience when using R2DBC in your application. We also want to deduplicate efforts that needs to be done on the driver or implementation level. See, we with R2DBC are pretty late to the party. Beginning in the early 2000s, JDBC emerged as a standard. And because we are late, we can learn from the things that JDBC went through and try to make things different in order to make lives easier for everybody who wants to provide an R2DBC driver. And that comes also with the aspect that we have shrunken down the API surface that is required to be provided by a driver. And in fact, it's not only an API, but also it is an SPI, which stands for Service Provider Interface. The driver implements that service provider interface, passes the TCK, and then it's an R2DBC compliant driver. And all this is to enable multiple humane client libraries on top of the R2DBC specification. R2DBC is targeting mostly the interoperability layer between the driver and a library that is sitting on top of that. Because productivity comes from the library that you are using within your application code, and you do not want to keep yourself busy with all the resource management and all the low-level API that a driver brings. You can, if you wish so, but you're much more productive if you are using something on top of the specification. Now, what can you do with R2DBC 08, which was the initial release 2 years ago already? Yeah, it was in December 2019 when we released R2DBC 0.8. And the 0.8 is also a signal that we wanted to ship something that can be used in production, but still we are on the path of an evolution. And this evolution might incur things like missing backwards compatibility when evolving the specification. We will get to 1.0 later on during the presentation, but for now, let's stick with the 0.8 version. With the initial release, you were enabled to leverage R2DBC drivers within your application code to provide an end-to-end non-blocking and reactive experience throughout your application. And you could do things like batching. You can fetch and store large objects. There's support for an extensive type conversation between various types. So for instance, if you are working with a temporal type, something like a date and time, and you're interested only in the date, then you're retrieving only the local date part or the local time part. And from that time on, you work on with these values within your application. We have a modern type system that makes use of these new Java types. We have own types for blobs and CLOBs. We have support for transactions, for save points. We are able to leverage database-specific features that make sense in reactive context. But those things are typically outside of the specification. A driver, like the Postgres one, can offer PubSub functionality or logical decode that you are able to leverage in order to send messages or to consume the replication stream. R2DBC drivers build heavily on service discovery using Java's service loader. Each driver can register itself, and R2DBC is going to look up the appropriate driver by using a standard URL connection format to find your driver on the class path, to load it, and to configure it. And finally, we have categorized exceptions that makes life easier. Instead of having a single exception type or an uncategorized exception type, and you need then to inspect the SQL state and or the error code depending on which vendor you're using, you can rely on an exception hierarchy that would tell you whether it's a time mode exception, whether it was a rollback, or simply bad SQL. With the specification, an ecosystem has grown. And this wasn't initially intended, but rather we started with something that we wanted to fix, which was namely, there is no standard how to integrate SQL with reactive programming. And out of this, a specification emerged. The specification was picked up, and a lot of driver vendors and client implementations have started building on top of R2DBC. See, there is the specification artifact. There is the specification itself, which you can download from Maven Central. There are central components like R2DBC proxy and a connection pooling component, so that not every driver needs to implement these aspects into their driver, but rather you're using the driver and adding then either the R2DBC proxy, which gives you observability and tracing possibilities, or if you require connection pooling, then you just wrap your driver within the connection pool. We have a huge list of client implementations, starting from Juke over Micronaut up to Spring and test containers. There's an entire community that is maintaining and building drivers, beginning with a Google Cloud Spanner driver. There's one for MariaDB, one for Postgres. And what I've heard so far is that Yugabyte is as well working on their own R2DBC driver, which you might want to check out in the future. Now, how does actually R2DBC could look like? Because all these were slides, but if we want to go into code, then we want to really see how this looks and feels like. And with R2DBC, you begin at the connection factory level. This is the entry point for every driver that allows you creating connections. Once you have created a connection, you create a statement, you run it, and afterwards you map the result and extract it. And then you finally get a publisher of values. And this can be either scalar values, like in this example, where we are returning a string. You could plug in an object mapper into the mapping process that maps and materialize an entity out of that row. So you have all the freedom that you need, and you can consume rows as you like and as you go forward. On the configuration side, there are multiple ways to configure R2DBC, and this pretty much depends on your usage scenario. You can use the API with connection factory options to provide all the values yourself. And this is handy if you are working within a test environment, or if you simply want to configure the API yourself. But besides that, you are also able to leverage standardized connection URLs. The connection URL has a scheme and a series of prefixes. It has a standardized way how to specify the host, the port, the database, or even a socket. You can specify vendor-specific options within the query string. And by handing in that connection URL, you then ask R2DBC to look up the driver to configure the connection factory accordingly. And from that time on, you're using the connection factory. If you look closely, then one thing is missing here, which is the authentication aspect. And authentication information and plaintext URLs don't play well together. So what we thought would be also nice is if you could hand in the connection URL to a parser that gives you programmatic access to what has been parsed. And this is as well possible that you parse the URL, augment the connection factory options with sensitive data like the username, password, or other things like encryption keys. And once you have created the connection factory's option object, then you ask connection factories to obtain you the configured connection factory. And there you have then added secure information into your configuration without actually exposing it to that environmental URL. Now we've seen a bit of R2DBC 0.8, and let's have a look on R2DBC 0.9. 0.9 is the current version in development, and we have seen already a few milestones from the 0.9 development line. And if we have a look on the actual changes that we see there, then you will find a whole list of things that we added there. And the reason for that we are seeing so much changes is not that we have forgotten those in 0.8, but rather with 0.8, we wanted to bring a version that can be used in production and add all the additional things that we learn from that are necessary in a later version. And this later version is R2DBC 0.9. We have things like extensible transaction definitions, improved bind parameters. We are able to specify in and out parameters, to invoke stored procedures, and much, much more. And for you, I've picked two features, which are the extensible transaction definitions and the improved parameter definitions to walk you through these. So let's have a quick glance on that and why this even matters. See, if you start a transaction, then you typically have a definition and an imagination how this transaction should be characterized. You have things like an isolation level. You know probably upfront whether this is a read-write or read-only transaction. You probably have things like additional transactional attributes, which is a name of a transaction, or whether it should be deferred, or log timeout, statement timeout. See, an entirely huge series of things that you could specify when starting a transaction. And the typical way how you do that is that you set the isolation level, then you set the transaction mutability, and then you call begin. And these are already three things, right? And every time you are interacting with the driver and the database, then you are having a conversation with the database, which means that we have issued 3 calls to the database. It would be much more effective and efficient to transfer and communicate all these details to the database in a single call. And this is what extensible transaction definitions is about, that you specify how the transaction should look like, and then you send all this to your database within a single round trip. You define the transaction itself through an extensible interface. Depending on which features your driver supports, you can specify only a base set of these attributes or additional features that you might to leverage from your driver. And then you call the begin method and simply go. And examples for these extensible transaction attributes could be the mutability or deferrability on the Postgres side. If you're working with SQL Server, then you can provide things like a transaction name, log timeouts, and mark within a log. And this mark is not me, but rather something within the transaction log that you then can later look up and use for your analysis or tracing possibilities. Another thing that I picked for you today is to show you how bind parameters are defined within R2DBC. What bind parameters actually are is that they are representations within your SQL statement where the actual value will be provided externally. And this means that you are no longer vulnerable to things like SQL injection attacks, where you concatenate strings and build the SQL on the fly, including all the values inline, but rather you define a placeholder depending on your database system. This might be a question mark or $1, $2, and these kind of things. And afterwards, you bind and provide the parameter to that statement. Typically, bind parameters are used within prepared statements where you send the statement once to your server, and then you get it back as a reference. And on subsequent calls, you only provide a reference to that statement and a series of parameters, and then you invoke that. Now, our approach to that is using zero-based indexes and name parameters. There are other approaches like ODBC or JDBC that use one-based indexes, but in our time where almost everything of Java is based on zero indexes, we found that it is easier to stick to a zero-based index scheme or even enable named parameters instead of anonymous parameters. And that makes it much more easier to look up which parameter is really referred to, instead of you having go to the SQL and then counting positionally which one is meant. Right now, in R2DBC 0.8, the currently available version, we derive the database type from the actual value. And yes, you've heard right, we're deriving a type. And this is important because databases require a specific type. They have to know which type of value you are sending to them, so that they can do the binding accordingly. And another thing that is true for R2DBC 0.8 is that we have in parameters only. So with R2DBC 0.8, you do not have the possibility to register out parameters, which might be needed for stored procedure arrangements. With the improved bind parameters, we can specify the directionality So this is the thing that will come with 0.9. And you have also the possibility to specify the actual type of the value, not only derive it, but specify either from a collection of predefined types like varchar and varchar and these things, or you can even specify vendor-specific types. In the Postgres environment, you have a very extensible type system where you can define things like enums yourself, and providing that type to the bind parameter allows you then to use Postgres enum types natively without having to tweak the SQL statement. Now, how does this look like? Well, we already know that connection has a create statement method where you define that statement. And within those statements, we see parameter placeholders. In the first example, these are the things with the add character in front. We bind parameters, either plain, where we are binding the value of Walter to add p.0, or where we can define the type and the characteristics of a parameter. So for instance, the greeting parameter should be an out parameter for stored procedure. And then we have to also specify which type is going to be this parameter type. And we can specify, okay, parameters.out with a specific type of varchar. The second example is much more interesting because it leverages the dynamic type system. Postgres allows, as mentioned, a creation of your own types, and enums is one of the poster child examples that we can leverage. And in order to insert a value of an enum type, we either have to cast that value into that type, or when specifying the parameter, we can provide that type. First, we need to look it up from the PG types table, and later on, we can refer to its internal ID by using the parameters in factory method, hand in the value type, the actual value, and then the driver will send the value as that specified enum type. Now, we've seen a few things that will come with R2DBC 0.9, but the journey is not over there. We are working towards R2DBC 1.0, and the journey continues, and R2DBC is here to stay. We are aiming for a feature-complete version of R2DBC, which will then still remain the de facto standard. And we see a pretty wide adoption across the community, across driver vendors, application frameworks, and the like. Now, R2DBC solves one problem, which is the non-blocking access towards SQL databases by providing a stable SPI for interchangeable drivers on top of a modern type system. Now, what I'm working actually up to is to make a comparison towards Project Loom. If you are into scalable applications, then you probably might have heard of Project Loom, which is an initiative to deliver high throughput, lightweight concurrency to the JVM, built on top of virtual threads. And there, again, a question arises: how does R2DBC compare to Project Loom? And to understand the answer to that question, we need to have a closer look on these things, what those things provide and what those are. Project Loom is a virtual threading endeavor that rewrites major parts of the JVM so that you can run blocking code as if your application was using non-blocking utilities from the get-go, from the start. And this gives applications, especially existing applications, a huge boost. You can remain with an imperative programming model, and you will benefit from a lot of these improved scaling behavior, because once your thread is entering blocking code area, then it will be put aside and resumed later on once the blocking part is over. However, it doesn't have any cancellation in its protocol because it's not a protocol. It's just a different way how to run code. And it doesn't have anything related towards back pressure. and we do not really know when it's going to be available. R2DBC, on the flip side, is a data access specification. So it is something entirely different from Project Loom. It is built on top of reactive streams to enable a reactive programming model, and it allows end-to-end streaming of data. While with Loom, you still have to work with existing APIs. With R2DBC, you can leverage publishers from end to end. We have backpressure support within R2DBC, and we have cancellation support within R2DBC through building on top of reactive streams. And it's already available. And as you see, these are two different things. And the gist out of that is there is no versus, because Project Loom solves different things than R2DBC does. And it basically boils down to the question, why do you do reactive? If it is for scheduling efficiency, then probably you want to check out Loom and remain within your imperative programming model. If it's more than just efficient CPU usage, then probably reactive is your better programming model. And that's where R2DBC is really shining. The future plan for R2DBC is to stay on Java 1.8 and remain on reactive streams. And the planned GA date for 1.0 is going to be somewhere next year, middle 2022. What we will see are a few minor refinements and cleanups within the API itself, but everything else will stay the same. R2DBC 0.9 is already feature complete, so R2DBC 1.0 will be pretty much what we have today with R2DBC 0.9. And this is all I have for you today. Thanks everybody for participating. If you are interested in a few further resources, check out the website r2dbc.io or connect via Twitter or GitHub with us. And now I'm happy to take questions if you have any. Thanks a lot. Take care and bye-bye.